Consider the integral. This is a wild-looking integral. This can be transformed into a basic integral by letting u be what? Well, this would be a little tricky. Normally, we would think we'll let u be the inside, right? Like 5 sine theta. If you do that, it just won't work. You can try it. It won't work. It's important. It might be valuable for you to try it and see that it won't go anywhere. In reality, you've got to let this whole piece here be u. You can tell that's what they did. There's the answer key right there. So I'm going to let u be the whole piece. A lot of times with u substitutions, u subs, you just got to try stuff and see what happens. Let me show you. What I mean is you got to do the du. So I'm going to do du d theta. This is a 5 here. And now, do you remember how to do the derivative of natural log? It's 1 over the argument, whatever's in the argument, times, because the inside is not a simple x, the chain rule right here, I'm going to do the chain rule right here, tells you to multiply by the root of the argument. What's the root of sine? The 5 just sits there, cosine, right? Root of sine is cosine. Remember, whenever we take the derivative with a number multiplying the front, that just sits there as a spectator, and the root of sine is cosine. That was the chain rule that made that happen. So again, natural log is 1 over the argument, but it's because the argument was not a simple x times chain rule system times root of the inside, root of 5 sine is 5 cosine. Okay, so what? Well then, multiply both sides by d theta. This is over 1. These 5's cancel, so we get du is cosine theta over sine theta d theta, right? The 5's canceled. Cosine over sine d theta. And what is that? What's cosine over sine? Do you remember from your trig days that that's cotangent? Cotangent is cosine over sine. Do you see how beautifully that works? That's the trick. It's just a trick. You do have to remember the tangent is sine over cosine, and cotangent is the upside down of that. Cosine over sine, it's right here. Cosine over sine, that's cotangent. So du is cotan theta d theta. Cotan theta d theta, okay? And why is that so great? Because now it makes that integral come together or come apart, however you want to say it. It becomes the integral of, so I'll just keep it cotan theta for a minute. Cotan theta times u times d theta, right? Because you got the cotan theta in the front and the d theta in the back. The whole middle part, ln 5 sine theta, that's u. That's u right there. So now you know what's going to happen. What is cotan theta d theta? Cotan theta d theta is the same as du. So that's just du. So this becomes the integral of u. Here, I'll keep the colors the same if that helps. Of u times d theta. Or I'm sorry, du. Let's get that straight. Try that again. Du, right? Because du is what replaces cotan theta d theta. Du is cotan theta d theta. So it becomes u du, u to u to u. Sounds weird. All right. So there we go. Now integrate with respect to u. So now we do the integral. How do we integrate that? And bring that on down here. So the integral of u du, that should be easy. The integral means anti-derivative, right? These operators operate on it. Well, how you can do that? Well, that has a 1 power. Add 1, that becomes u squared and divide by. It's a half u squared. A half u squared. They have the constant force. And then last step, now the half u squared, plug in. What was that u all along? Remember, u is ln 5 sine theta. Ln 5 sine theta. Ln 5 sine theta. There's a lot of parentheses there. Ln, oh wait, it was ln, yeah, ln 5 sine theta. Um, oh, this answer, I guess I have to fix that answer. Yeah, it should be ln 5 sine theta. Ln 5, because the u was 5 sine theta from the beginning, the u is ln 5 sine theta. So the u right there, the u is ln 5 sine theta. And there we go. They have the plus a constant already there for us.